tell you. Now, another time I will tell you vector. Okay. Now, vector analysis is a subject that is better taught by mathematician than engineer. Engineer. Basically, I read vector analysis for physical sciences. Now I'm doing mechanical engineering also, but it's related with electrical engineering. And yes, in mechanical engineering there is so many necessity in electrical engineering also. Now it is my enthusiasm that I want to teach you on vector analysis. So okay, now I will show the part of vector. Now look, vector. First, I will tell you what is vector. I think I tell you that what is vector. Vector basic vector is made basic displacement basic displacement block. Is clear. Now vector is nothing but a part of tensor. Vector is nothing but a part of tensor. And what is tensor? What is tensor? It is this is 1D, this is 2D in a board, and that will be 3D. Y, X, Z. This is for X, this is for X, Y, 2D. Now, this is our dimension. We know basically 3 dimension of the space, and in STR, in special theory of relativity, there is a 4 dimension, 3 dimension for space, 3 dimension for space, 1 dimension for time. This is for the STR. Now, what I say, vector is a special case of tensor, and its rank is 1 for the tensor. Okay, its rank is 1 for the tensor. Vector rank 1 tensor. Now, what is the second part? I will say what is parity transformation, inversion of coordinate. This inversion of coordinate called parity transformation. There is so many coordinate. So many. I think Cartesian coordinate, cylindrical coordinate, cylindrical coordinate, spherical coordinate, then system after. Okay, now for the Cartesian coordinate x, y, z, if we transform minus x, minus y, minus z. In cylindrical coordinate, there is r, theta, phi. If we transform it, it will become r pi minus theta and pi plus phi. Spherical coordinate, there is this is spherical. Now the cylindrical is s phi z. Now this is that will be s phi z, s pi plus phi and minus z. This is all. Now this this is my note, page number 1. Now I will teach you note 2 here. Now this is look, this is coordinate y, x, z. If I inverse it, how it will be behave? Like this. Okay, y will be here, this is y, z will be here, this is z, and x will be there, this is x. So this is minus y, minus x, minus z, and it is right, this is left. Okay, now that will be parity. So what is parity transform? Parity transform means RHS will be converted into LHS, and if something invariant under parity transformation, that it means it's same when you observe it from RHS and from LHS together. Can I write it? I can write it for you. If something is invariant under parity transformation, what it means? This question, the answer is, if parity transformation means RHS will be converted into LHS, and if something invariant under parity transformation, that it means it's same when you observe from RHS and from LHS. So for example, for vector, the A vector, if parity transform it, that will be minus vector, sign will be change. Okay, in pseudo vector, right, A vector plus B vector. For example, if I change parity transform, it will minus A vector plus minus B vector, minus A vector plus minus B vector with A vector plus B vector. So pseudo vector will not change sign. There is so many. A vector plus vector will be pseudo vector. Vector plus vector will be pseudo vector. That means pseudo vector. Vector plus pseudo vector. There is so many examples now.